Welcome back, Honors Algebra 2. Yep, that's what we're making the video for. Hope everyone's doing great. We're going to finish up with the notes for 5.1, which is composite functions. Okay, so hopefully you've already watched part 1, because it would be weird if you didn't watch part 1 and then you headed into part 2 because you missed some of the important information. So if you haven't watched it, please go back and watch it. Okay, so f of g of x, first thing I'm always going to do is just start by rewriting it. F of g of x. And then what I want to do, okay, so I have g of x. Let's see, I'm going to write these to the side. My camera is like super crooked right now, so my paper is crooked and then it's throwing me off. I'm going to try that, see if I feel better about that, which who knows. Okay, so f of x is equal to rad 3x minus 5, and g of x is equal to negative 2x minus 1. So when it says f of g of x, that means we're going to take g of x, the entire function, so negative 2x minus 1, and we're going to plug it into the function f wherever there's an x. So there's only one x here, so we're going to plug that in. So that would get me the square root of 3, and then instead of x, we're going to plug in negative 2x minus 1 minus 5. And that's still all inside the square root. So then I would just simplify. So I distribute the 3. So the square root doesn't really change. And I have negative 6x minus 3 minus 5. And then I can combine my like terms. Negative 3 and negative 5 becomes negative 8. So I have my final answer. So f of g of x is equal to the square root of negative 6x minus 8. And that is it. So then we need to find the domain of my composite function. So remember, this is 2 parts. We have to first find the domain. So let's see, we're going to find the domain. So you first have to find the domain of the function that was inputted. So the function that was inputted was g of x. So we have to do that first. And g of x, negative 2x minus 1. If we look back to like our refresher from video 1, remember we have 3 types of domains. Polynomial, radical, and rational. So is negative 2x minus 1, is it a polynomial? Is it a radical? Or is it rational? And if you're saying it's a polynomial, you're correct. And so that means whenever it's a polynomial, the domain is always all real numbers. Okay, and then we have to find, so we found the domain of the inputted function, and then step 2, find the domain of the new function. Okay, so is this a polynomial? Is this a radical function, or is it a rational function? And if you're thinking it's radical, you would be correct. And so remember, when we do that, we take the inside of the square root, so negative 6x minus 8, and we set it greater than or equal to 0 and solve for x. So I would add 8 to both sides. Divide by negative 6. Remember, when I divide by a negative, that means I need to flip the inequality symbol. So when I divide, I get x is now less than or equal to 8 divided by negative 6, which is going to simplify to be negative 4/3. Now I have my 2 domains. all real numbers, and x has to be greater than or equal to negative, or less than or equal to negative 4/3. So we have to think, okay, how can I write that combined? Well, if we're thinking about it in terms of like a number line. So the first one is saying, okay, it can be all real numbers. It can be everything, any number possible. But then the second one is saying, well, no, x has to be less than or equal to negative 4/3. So now it's saying this one. So when I look at where do these two overlap, well, these two overlap at the less than or equal to negative 4/3. And so that's my new domain. And we always want to write it in interval notation. So it's going to be negative infinity to negative 4/3, parentheses on the negative infinity, bracket on the negative 4/3. So you're essentially looking to see where do the two domains that I found, the inputted and the new, where do those overlap? Okay, so if you guys are feeling good, you guys can try part B on your own. If you guys want to do it with me, great. Whatever you guys want to do, I'm going to do it anyway. So, okay, we're going to start again. I'm just going to rewrite it. G of f of x, which means now we are inputting f of x into g. So I'll just write those two on this side. F of x is equal to 3x minus 5. I'm only just writing these for, to see the colors. Okay, so we are inputting f of x. So the entire square root of 3x minus 5 into g. So wherever there's an x there, we're going to input it. So that's going to be negative 2. And then in for x, we're going to put the square root of 3x minus 5 minus 1. Now, negative 2 is on the outside of the square root, and 3x minus 5 is on the inside of the square root. So can I multiply something that's on the inside with something that's on the outside? And the answer is no. So this one's actually really kind of weird, and then also kind of easy because you don't really have to do much. The way that we would write this as our final answer is, so g of f of x would be equal to, I didn't want to start the square root yet. So negative 2 square root of 3x minus 5 minus 1. Be careful. The minus 1 is not inside the square root, so you want to make sure that you don't put the square root all the way over. So that would be my final answer. It's kind of a funky looking function. But okay, so then what we're going to do is we're going to find the domain. So remember, first we need to do is find the domain of f of x. Because that's the one that we inputted in for. So that one, I'm thinking, okay, is that a polynomial? Is that radical, or is that rational? And that one is a radical function. So what we're going to do is we are going to take the inside, which is 3x minus 5, and set it greater than or equal to 0. And then we can solve for x. So we would add 5, divide by 3, and I get x is greater than or equal to 5/3. Okay, so then actually the domain of the new one. Now, I know this one's kind of weird, but with this one, it's still a radical function, even though there's parts that are on the outside, And all that we worry about are what's on the inside of the radical. So it's still the 3x minus 5. So it's actually the same exact domain here. X has to be greater than or equal to 5/3. And so my domain for the composite function is just x has to be greater than or equal to 5/3. So I'm just going to write that here. And so that would be 5/3 to infinity. Okay, so that is it for 3. We're going to move on to 4. Last one, and then go from there. So, okay, so 4, we have 2 rational functions, right? They have x in the denominator for f of x and x plus 4, so variable in the denominator for g of x. Okay, so we are going to start. I'm just going to always rewrite f of g of x. So I'm just going to write them to the side. So f of x is equal to 2 over x. And g of x is equal to x squared over x plus 4. Okay, so we're taking g of x. So the entire x squared over x plus 4 and plugging it into f wherever there's an x. Okay, so let's do that. 2 stays the same over, and then instead of x, we're going to put x squared over x plus 4. Now, what have I always taught you guys? When you have a fraction over a fraction, or like just a number on top and there's a fraction on bottom, what are we going to do to make this problem easier? And if you're saying split it apart, you would be right and write it as 2 separate fractions. So it would be 2 over 1 divided by x squared over x plus 4. And so now what we can do is take the reciprocal of the second one and multiply. So 2 over 1 times x plus 4 over x squared. And now I can really, you can write it one of 2 ways. So you can either write it as 2 times x plus 4 over x squared. I don't care if you guys multiply it. But if you do, if that is something you want to do, you can write it as 2x plus 8 over x squared. So both of those would be completely correct. I don't care which way you write it. Both answers are good. Okay, so now let's go into the domain. So the domain, remember, the domain is going to be 2 parts. So we're first thinking of what's the domain of what was inputted. So the inputted one was g of x. So we're doing first the domain of g of x. And so we're thinking, okay, is this a polynomial? Is this polynomial? Is this radical? Or is this rational? And I already said it in the beginning. These are both rational. They have a variable in the denominator. So remember, when it's a rational, we need to find the excluded values. And we do that by taking the denominator, x plus 4, and the denominator can't be equal to 0. So then I solve for x. So I move the 4 to the other side of the equation, and I get x can't be equal to -4. So that's part 1. That's just finding the domain of the input. Then I need to find the domain of the new function that we just came up with. So again, we're thinking, what type of function is that? Is that a polynomial? Is that radical? Or is that rational? And again, that one is rational because there's a variable in the denominator. So we're going to set the denominator, which is x squared. X squared can't be equal to 0. Okay, so then we would just square root both sides of the equation or non-equation. And so that would be x can't be equal to 0. So remember, we have to write that as 1. And remember, when we had 2 excluded values, this was last semester when we did that, and we would write it, it was long, but we would write it using parentheses. So if you guys need to, sometimes to help you guys, I would write it out on a number line, just like I did up there, and I'd say, okay, so x can't be equal to -4, and it can't be equal to 0, but it can be equal to anything else. So the way that we write that, let's get that. So the way that we would write that, the domain here would be -infinity to -4, but it can't be equal to -4, so we use a parentheses. So -infinity to -4, union, -4 to 0. Again, we're all using parentheses. And then 0 to infinity, union, 0 to infinity. And that is my domain. It's my final answer. Okay, so if you guys are feeling good with A, I want you guys to pause me here and try B on your own. So you guys can try B. B has a little bit more to it, but that's okay. I would still really encourage you guys to try as much of it as you can before coming back and checking my work. So I really encourage you guys to kind of try these things on your own first. Okay, so first thing, if you've tried it, if you haven't, okay, I'm getting to it now. So first thing I would do is rewrite. So it would be g of f of x. I'm going to write both of those to the side here. So f of x is equal to 2 over x. And then, sorry, my cat Rusty is on my lap right now, and he's trying to get into the screen. So he might just hop up into the video in a minute. This is just where distance learning has come to. Okay, so g of x is equal to, and he's making his move. Can you see his paw? Oh, okay. He's going down, sorry. Okay, so g of x is equal to x squared over x plus 4. So with this one is just like the opposite, right? We're taking f of x, so the entire 2 over x, and we're plugging it in wherever there's an x. So it's 2 spots here. That's why I said it's a little bit more involved. Okay, so instead of writing x squared, we're going to write 2 over x squared all over 2 over x plus 4. Okay, first thing I would do is separate. Just like we did before, I want to separate. So this I can square this in my head, right? It's 2 squared and x squared, so it would be 4 over x squared. And then divided by 2 over x plus 4 over 1. Now, remember, we've done this, I think. Yeah, I think we've done this. Remember, whenever you have like a fraction and you are dividing, before you can take the reciprocal and multiply, you want to get a common denominator. So the common denominator between x and 1 would be x, so I'd multiply top and bottom by x. So that would be 2 over x plus 4x over x. And now, because they have that common denominator, I can write it as 1. So 2 plus 4x over x. And this one was already one fraction, so we don't have to really worry about that. So now what I do, I have one fraction on the right and one fraction on the left. We're good. We can take the reciprocal of the second one and multiply. So 4x squared times x over 2 plus 4x. And we actually can simplify a lot here. So the first, like right off the bat, I recognize that there's an x on top and an x on bottom. I can cancel out one of those. And 1x there and then 1x on the bottom. So I'd be left with 4 over x times 2 plus 4x. Well, then I'm thinking 2 plus 4x, those both have a common factor of 2. And on top, we have a common factor of 2. So I can divide everything through by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So my final answer here would be 2 over x times 1 plus 2x. If, again, just like up above, like if you wanted to distribute that x and get x plus 2x squared, that's fine too. So that would be my final answer. My pen is running low, but I'm going to power through it. I don't have another blue pen like this at home. Looks like I have to go into the classroom. Okay, so last thing we have to do is find the domain. So if you guys are here and you got here, what I want you guys to do, pause me here. I want you guys to think about the domain on your own. So think about what the domain of the composite function is going to be. So you should be coming back. You've already thought about the domain. You already have it written down. You're just checking your work. So you can always fast forward through my explanation, but, I'm still going to explain it. So first thing we do when finding the domain is find the domain of whatever was inputted. So this one was f of x. So that's, oh no. Ugh. I don't want to switch to black. Good news, everybody. I found a new blue pen. I know, magic of pausing. Oh, look at that pen. Okay, so the domain of f of x. Okay, now it's just like, overcompensating. Okay, so for the domain of f of x, we set the denominator. It's a rational function. Holy cow. Okay, so we'd set the bottom. X can't be equal to 0. That's it. That's solved. It's our first excluded value. Then what we need to do is find the domain of the new function. So we set the denominator, x times 1 plus 2x can't be equal to 0. Now it's fully factored. Sorry, my head was in there at that moment. I'm so sorry. I have to sometimes when I write get very close to the paper, so it's hard for me to not put my hair in there. You can tell that my hair is in a very messy ponytail right now. Okay, so we'd set both of those factors can't be equal to 0. 1 plus 2x can't be equal to 0. This one's already solved for, and it's the same as up here. And then this one we'd solve. So 2x can't be equal to -1. X can't be equal to -1/2. So we have 3 excluded values. Really, we have 2 because 2 of those are the same. And then we'd write it in interval notation. So the domain, I'm going to write it, I'll write it right here. So the domain would be -infinity to -1/2, union, -1/2 to 0, union, 0 to infinity. And if you guys need to write do the number line, just like we did up there, to think about which one's going to come first. I mean, it always, whichever one is less is always going to come first. You order them from least to greatest. So we think, okay, it can't be equal to -1/2, and it can't be equal to 0, but it can be equal to everything in between. So it would be -infinity to -1/2, -1/2 to 0, and 0 to infinity. And that's it for 5-1, guys. Perfect timing since we have the lawnmower going on outside. So I hope you guys have a good day. If you guys have any questions, please come into office hours, get those answered. I'm happy to help. Even if it's not office hours, you guys can always shoot me an email. I'm happy to, get on and respond. If I don't respond, I will probably the next day. So, I'm always here to help. So I hope you guys have a good day. I'll talk to you soon. Bye.